In this chapter, we cover modifying pixels by position. You will notice a lot of our content in this chapter has previously been seen in chapters 4 and 5. Here, we have our media learning goals for this chapter. Here, we have our computer science learning goals for this chapter. Run this code, but take each comment labeled 1, 2, 3 out each time. You'll notice they're labeled as comments. Take the comment out and run one at a time. You will notice your correct answer is number 3. We previously covered how pixels have an X and Y like a graph. Arrays are 1 by 1, matrices are not. Here, we show our graph with our X and Y for our pixel. Can you figure out why we receive our error message? Think of a range like in Excel. It is an area where information is stored. The bracket here represents an array. If there is more than one parameter in the range, it is a sequence. We can use a range to create an index of numbers using multiple loops. We have previously seen this example of having to move our X and Y at the same time. Can you figure out what X changes to the second time through the loop? The same we do to X needs to be done to Y. Once we have our pixel location, we can change our red coloring. Our for loop changes the pixels in a quicker fashion, but still goes one by one. We continue to work through the code to change our pixel. Again, we continue to work through the code to change our pixel. We have previously seen lightening and darkening an image. Here is the code as a nested loop. Run each program's code to find the answer. You will find that number 1 is A and number 3 is B. Our previously seen red eye removal program can also be rewritten with nested loops. Using an imported class called clock, we can use timing methods. We have seen this in chapters 4 and 5 previously. We can reuse code, but there are times our code is only used once or needed once. We have previously seen these utility functions in action. We have previously seen all of these slides in chapters 4 and 5. Run this code. See whether 1 or 2 created this. You'll find the answer is 1. Try out each comment as a statement at a time to find the right answer. That is, remove the comment and run one at a time. You should find out that A is number 2 and B is number 3. Again, we have seen all of this in chapters 4, and 5 previously. Here, you find different examples using the same cropping function. Again, we have previously seen this in chapters 4 and 5. In order to generalize our code so it works in all cases, we can use the following. Can you determine the answer without running the code? Run the code and see what happens. You should find the correct answer to be number 4. Here, we are in essence creating a collage of pictures. Again, all of this we have previously seen in chapters 4 and 5. Here, it is shown how we can compute an average of 4 colors to create a new color. Notice the new color still has all of the RGB parts. We can use different functions to edit our images in different ways. We can use code to blend pictures together. Here is an example of 2 pictures being blended together. Here we have lengthy code to blend 2 images together. In theory, the bigger our canvas is, the more pictures we can fit into it. We can also draw lines on a picture too. We can also get or set a color as we have done previously. Remember our to-do list or recipe suggestion. We need to make things easier on ourselves. Here are some functions we can use to draw on our canvas. In case you don't know, filled fills the object up with color. Rectangle filled is a filled rectangle. Here, we created code to add a red box to our beach image. Notice? Here, we run all 4 of our functions, showing exactly what they do. Add text creates text. Add line creates line. Add rectangle creates rectangle. Add rectangle filled creates a filled rectangle. Code is generally stored data, much smaller rate than an image. Other times, this is not the case. Think of the program Nedry wrote to run Jurassic Park as an example of lots of code. Vector-based graphics are retrieved for us. A Flash file will have a different extension than JPEG, BMP, GIF, and other common picture formats. Think of the example of videos for this course. It took longer to load when the videos were stored on Canvas, but load quicker now with the embedded YouTube code. A computer interprets vectors and bitmaps differently. When you make a JPEG bigger, you notice the distortion of the image due to this. A program is the entirety of our code. We noted early on in this course, colors can be seen differently by different people and computers. Here is yet another example of that. Here we are building 3 different graphics using our code. Writing programs in JES especially limits how much we need to know to get our result. Our programs, once we compile and run them, execute our procedures for us.